Okay, welcome back, everyone. Now we want to show you the apps in action. So the first app we're going to show is the Iris app, and you may have seen something like this before. It's a well-known model and prediction out there, but we're going to show you an application that's running. It's based on Streamlit, and it'll be running on the cloud and running in the application so you can interact with it. But the cool thing about it is that it's actually going to make calls out, send the data that you're manipulating, and then get the prediction back, the real results. So Nick, why don't you show us how this runs?
Absolutely. So we have here a write-up in the blog about what it is and how we built it. But probably a better way to see that is at the bottom, we link to the GitHub repo and the application itself. So go ahead and take a look at the app. There's a welcome screen, and what we're really interested in is the demo itself. So at the time of filming this, there are 2 demos, and at the time you watch this, there may be more. So go ahead and click on the iris demo. And like John said, what we're doing is predicting which species of iris a particular flower petal belongs to. There's 4 numerical features, which map to these 4 sliders here. And we can go ahead and press predict and get a response back. So this is just predicting which species of iris flower these values would correspond to. And so this is kind of nice. We can go ahead and change the slider, interact with the application, press predict again, and I get something different back. So we're just displaying what that prediction is here, and we get the raw result right here, which is just a numerical value, 0, 1, or 2. So which class does it belong to? So this is cool, but I would say the more exciting part is how are we actually interacting with the model, and how did we deploy the model? So in terms of interacting, there's a section here called inferencing. And so they're really only doing this in 2 or 3 lines of code. One is getting the data, and in this case, the data is coming from our sliders. So for example, I could move these sliders around, press predict again, and you'll notice that the data updates. So we got live data coming from our user, and then we're going to send it to our model. We actually have 2 ways of doing this here. One is using our mock server, and this is just for testing things out, whether you're in your Jupyter Notebook or your IDE. It's a simulation of your model server, and it's a really good way to make sure that everything's working like you want it. And then once you're ready to go to production, you deploy it to your endpoint, and then here you can make a post request to your production endpoint. And this is how you would typically interact with some sort of model from an application, is a post request to some sort of HTTP endpoint.
And this is cool too, because just that one line with the mock server, you run everything local. You don't have to worry about pushing or anything, hosting to the cloud. On the second part, when it is hosted or posted to the server, it's also cool because it's just an endpoint, right? And you're sending the data that you've entered in, and that's sent to the model or to the service, and then that's inferenced, and you get the results back. So, just in a few lines of code, you can do this, and it's pretty powerful, especially because different endpoints could have different models, and you can really test this out pretty easily.
Exactly. And you can even have more than one model in this endpoint. For example, here we're going to /v2 models iris. If we had another model that detected tulip based on which type of tulip species a particular flower petal belongs to, we could go to /v2/model/tulip instead of /iris. So you can have more than one model at each of these endpoints to interact with your application. So to round this off, I'd like to talk about the deployment. So how did we actually deploy the model to an endpoint? And we did this in about 4 lines of code. So what we did first is created a project. Not super relevant here, but it's nice to organize things into your projects. And then we imported our model server. And so what you can do is have reusable pieces, sort of like Lego bricks, that you can import and use across your different projects, one of which is our model server. So we imported that in, and then we went ahead and added our model. Before we were going to this /iris route, and this is where I named it. I named it iris, and I'm pointing to my model. In this case, it's a file in S3, but this could be part of your experiment tracking framework or wherever you're keeping your models. And then last, we go ahead and deploy our model either to our mock server, like we were using up above, or deploy it to our real-time endpoint, where it's going to package it all up, use a model server, take the router, deploy it on your Kubernetes cluster, and expose it to some sort of endpoint, all with about 4 lines of code.
This is also showing you the power of ML run here, is that, it's just, it's abstracted out really nicely. You're basically just doing a few steps to do this. It's no complexity. You're seeing the real code here. So we're really trying to, get this complexity put in a way where it makes it easy for you to change and update and use this without a lot of understanding of all the intricacies happening behind the scenes.
Absolutely. So in the next video, we'll go ahead and take a look at the heart disease demo, which is a little bit more complex and maybe closer to what a real model would be like in production. So we'll see you there.